Welcome. My name is Dominic Messina. I'm a second-year PhD student in Research Group Discovery, headed by my advisor, Dr. Helen Durand. And we're from Wayne State University in the Department of Chemical Engineering. The title of the talk today is going to be Forward Image Prediction for Environment Exploration using Model Predictive Control. The current state of artificial intelligence research does well predicting familiar scenarios. However, performance could fall off when operating in unknown environments. When performing tests in an environment, visual data is often a critical source of information, especially for mapping terrains, identifying objects in the scene, and for predicting the dynamics of these objects. As humans, we tend to take actions based on how we think the environment is going to change, and then we take steps to collect the information when more is needed to succeed in our tasks. Likewise, as autonomous agents continue to become more prevalent for safety critical operations in cyber-physical systems in general, these agents require methods allowing them to explore their environment based on predictions of the future. With this in mind, we set out to provide a method using model predictive control to control the movement of a camera seeking to capture more information about a static object in its environment. Our prior research motivating this current research includes techniques for safety critical control. Specifically, we looked at a controller known as Lyapunov-based economic model predictive control, and we used a backup control activation to account for disturbances throughout a sampling period. Some of our current research is in exploring techniques for obtaining parameters used in safety guarantees for advanced controllers. And the goal of this is to increase trust in these controller designs. Based on this prior research and NASA's strategic plans, we decided to explore model predictive control with image-based control, see if we can make decisions based on predictions of how an environment will change over time. In our initial steps, we had decided to use object detection and tracking and an autonomous vehicle simulation software known as SVL. For the object detector, we implemented a design known as YOLO v4. And our objective here was to use object detection to identify objects in the scene with low confidence, and then to use model predictive control to steer the vehicle near the object to gain more information, hopefully to better identify the object in question. We decided to change directions more towards producing models of the environment, specifically models of an object in OpenGL, which is a graphics software. In this current direction, we would like to use model predictive control formulation to predict how a scene will evolve dynamically, and then use that to compute control actions with respect to an agent's goals. And in OpenGL, as I said, we'll be modeling objects with different characteristics. Specifically, our lighting model will be constant. However, we will model different materials for an object in the scene. Our current plans for this project are to use MPC to plan a path of motion for a camera in OpenGL, which will enable the collection of visual data. And we want to use MPC to predict different future image trajectories based on these different materials. And our objective here is to seek to choose a path which distinguishes object material as quickly as possible. Future work in this is going to aim to address issues such as scalability in material selection in order to make it more applicable to the real world. And with that, I'd like to gratefully acknowledge funding from Michigan Space Grants Consortium, Air Force Office of Scientific Research, National Science Foundation, and Wayne State University. Thank you.